All right, let's get right into it. We're about to look at a seriously mind-bending new idea, one that comes from the very edge of physics and asks us to rethink, well, pretty much everything we thought we knew about gravity and time. So let's start with a whopper of a question. For decades, we've been told that something like 85% of all the matter in the universe is this invisible, mysterious stuff we call dark matter. But what if it's not actually there? What if it's all just a big misunderstanding of how gravity really works? Now, to even understand why we'd ask a question that bold, we got to start with the man himself, Einstein. His theory of general relativity, it's been incredibly successful, for sure. But it's not perfect. It leaves us with some really big, lingering puzzles. And maybe the biggest puzzle of all is that galaxies are spinning way, way too fast. I mean, so fast they should have just ripped themselves apart by now. The standard explanation has always been dark matter, this giant invisible halo of stuff giving off extra gravity that holds it all together. But here's the catch. For decades, we've been looking for even a single particle of this stuff, and we found nothing. Zero. Which has got a lot of physicists wondering, maybe we're looking for the wrong thing entirely. And that's where our new challenger steps into the ring. It's a speculative, new theory, and it has a pretty radical solution for these puzzles. It's called chrono-gravity. So here's the core idea, and it's a big one. Chrono-gravity basically flips one of our most fundamental assumptions right on its head. In Einstein's world, we know gravity can warp spacetime and slow down time. But this new theory says, nope, you've got it backwards. The flow of time itself is the fundamental cause of gravity. And I mean it when I say this idea is brand new. It was just put forward by an independent researcher named Adam James Parks. So, this isn't in the textbooks yet. What we're doing here is taking a peek at the scientific process in action, right at the very beginning, when a new idea is just starting to take shape. Okay, so let's really dig into this central concept. What does it actually mean to say that gravity is caused by the flow of time? So check out the difference here. With general relativity, you have mass and energy bending spacetime, and the slowing of time is just a consequence of that bending. But with chronogravity, the flow of time is the main event. Just imagine that time flows at slightly different speeds in different places. This theory says that this difference, this gradient in the speed of time, is what actually generates the force that we all feel as gravity. It's a total flip of the script. Okay, that's a really cool concept, right? But how does that explain why galaxies are spinning too fast? If there's no dark matter, where is all that extra gravitational pull coming from? Now this is where the theory gets really clever. It suggests that the flow of time around a massive galaxy creates this kind of repulsive halo. They call it a time flux halo. And the craziest part? It isn't made of particles. It's not matter. It's a property of the time field itself. And when you run the numbers, this effect perfectly mimics the exact amount of gravitational pull we've been attributing to dark matter all along, but without needing a single dark particle to exist. Right, but any new theory, no matter how cool it sounds, has to do one crucial thing to be taken seriously. It has to make predictions that we can actually go out and test. And chronogravity makes three really bold ones. The theory predicts stuff we can actually measure. First, it says we should see specific, tiny differences in the gravitational waves we detect from black holes smashing into each other. Second, it predicts there should be tiny variations in how time flows that our best atomic clocks could pick up. And third, it offers a brand new, precise explanation for a weird little wobble in Mercury's orbit that's been known about for ages. That first one, the one about gravitational waves, is probably the most dramatic. I mean, these are literal ripples in the fabric of spacetime, and our detectors have gotten insanely good at picking them up. So, for a pretty standard black hole merger, chronogravity predicts that the peak signal, the biggest splash, should arrive 0.3 milliseconds earlier than Einstein's theory says it should. Now, 0.3 milliseconds, that sounds like absolutely nothing, right? But to our instruments today, that's a difference we can actually look for. It's a tiny window that could prove one theory right and the other one wrong. And what's really cool is that the author of the theory is basically throwing down the gauntlet. He writes that the theory is falsifiable, which is science speak for you can prove me wrong, and that it predicts new physics we can access today. He's not saying we have to wait for some far future technology. He's inviting scientists to test his idea right now. So let's just go there for a second. Let's imagine these predictions are tested, and they turn out to be right.
What would that actually mean for our understanding of the whole universe?
Well, the first thing to get is that this isn't about throwing Einstein in the garbage. Not at all. The theory is actually designed so that in most everyday situations, its new effects are super tiny, and the math just simplifies right back down to general relativity. It's an extension of Einstein's work, not a demolition, and that's often a sign of a really strong scientific step forward. But wow, the implications would still be absolutely revolutionary. The search for a dark matter particle, a search that's lasted decades and cost billions, it would just end. Our whole picture of what happens in the extreme gravity near black holes would have to be updated. And maybe the most exciting part? By redefining gravity from the ground up, it might just give us the new tools we need to finally build a bridge between gravity and the super weird world of quantum mechanics, which is, hands down, the biggest challenge in all of physics. And that's really the thought I want to leave you with. For almost 100 years, when we've hit a wall, we've looked for new particles, for new stuff, to solve the universe's biggest puzzles. But chronogravity suggests a totally different approach. It asks, what if the answer isn't out there somewhere waiting to be discovered? What if it's been right here with us the whole time, and something we experience every single second of our lives, time itself?